Hey guys, I'm starting a new series called Code Like a Pro, and what we're going to basically teach you is how to code professionally. It's pretty apparent when you open up somebody's project and it's a hobby or they're just starting out and they don't know how to improve their code, make it so that it looks professional, it looks readable, maintainable. These are all going to be things that I've picked up as my years as a developer, but also that I can't take credit for most of them because I read books and I do courses and I learn these from people with many more years of experience than I have. So what does it mean to have professional code? Like, what do I mean by that? Well, I want to give a sort of analogy to explain it. A lot of times when you're getting started, all you really care about is, does your code run and does it deliver the features that the client wants? Does it work? And it can, and I'm assuming it does in both situations where you're writing professional level code and then you're just writing some code where you're getting started and learning. It's sort of like comparing a treehouse to a home is how I feel like it. Like, there is something that's going to last the test of time, because we have written it in such a way that it's going to be maintainable and easily updated. And then you have a treehouse, which is going to slowly get worn down because we didn't build it in the proper way. Both are shelters. One's going to outlast the other. So what makes clean, maintainable code? Well, we're going to be talking about a whole slew of things in this series, and we're actually going to be giving specific examples, not just like, hey, you should do it this way. We are going to tell you how to do it this way and why, but we're also going to give coding examples. We're going to say, okay, when I say variable names need to be descriptive, and what does that mean exactly, and how can we showcase that our code will be now more readable by using something like object or array destructuring, for instance, to get us going here and actually see in real time how we can take this set of code and now we make it this set of code and it makes a whole lot more sense. So we're going to talk about code readability. You don't write code for yourself or the client even. You do because they're cutting the checks, right? So, but one of the reasons that you write code is you write it for the next person who has to maintain it, right? The average dev is at a job 2 years or something like that, and chances are that project's going to outlive you for a very long time. And so you need to make sure that you're writing the cleanest code possible, the most maintainable code. And to do that, you have to write readable code. So what is linting to those of us who are new to the concept? Well, linting really is two things, and these are always, whenever you're incorporating a tool, you have to answer what I call the big two, the what and the why. So what is a linter? It is a tool that you set up, essentially one time usually per project, that will flag errors, programming errors, bugs, stylistic errors, and suspicious constructs. What does that mean? It's basically going to catch syntax errors. That's it. It's going to find out if you're making simple mistakes in your code where, hey, you're declaring this here outside of its scope, and that's going to break. JavaScript is one of those languages where sometimes we don't find if that happens until we work our way through the application. So linters give us the opportunity to find those errors earlier and more often. It also adds to readability. What that means is we're going to make sure that our code is formatted in such a way that is the industry standard or is a standard for that language, that programming items. And that's the why. So it's going to catch errors, syntax errors, sometimes more than syntax errors. It's going to have trouble catching logic errors, but that's usually more so a developer issue, and we'll talk about how to catch those later on. This thing is something that can also be automated, so you don't have to run it every time. It's just there, and we'll start picking up good habits by just sort of being trained by the linter to a degree. And this will lead to more readable code, less buggy code, and we'll be writing in better standards because of it. So let's go ahead and jump into an example. Alright, so what we have here is a TypeScript file, which is just JavaScript. It's a superset of JavaScript. And what we're going to be looking at is, immediately, because he didn't intend this file to be TypeScript, we have some errors. So I'm not too worried about that right now. We should have some worries, but you'll see here, this is before we turn the linter on, by the way. And so what's going to happen here is we're going to go ahead and turn the linter on and see, hey, let's take this file. from someone just getting started and see how we could just clean up our code to follow the standards. And don't worry about the setup of linters. I will include, as I mentioned, 2 videos, but I'm going to go ahead and turn the linter back on and reload the app. And what we're going to see here is quite a bit of difference. Oh, there it goes. Just a little bit of a hiccup. So you can see that now there's something wrong with pretty much everything in this file. And this is, so where linters excel at is catching those small errors that are semantic in nature, or that are, we want to, anything that we can compare. They're not logic-based errors. There are structure errors. There are formatting errors, items like that. And so what you'll see here is that the standard for comments, for instance, is to have a space between them. And so that's something we can fix. You'll see here that in modern JavaScript, the var keyword is essentially forbidden. That's what the word they use. And you'll say, okay, this is something that we have decided that, use let or const. And so for the time being, we'll go ahead and change all the vars here. And there's quite a bit, right? There's quite a bit to let. So we'll change that to let. Go ahead and replace all of those vars. So we may have to change some of them to const. You'll also see that when we hover over this, the TS-lint is saying, hey, on average, you should be using double quotes to single quotes. That's kind of a silly one, but you can change that depending on your preference. But I think the more important point here is that you see double quotes here, single quotes here, is we want to have a set standard of what it is we're doing. You shouldn't have multiple ways of how you do things like this in your code. So let's go ahead and replace all the single quotes with double quotes. But you can see how we're slowly going to make this file just look a little bit cleaner. This isn't something necessarily the linter would do, but from a personal standpoint, I would say that you want your code spaced out evenly as well when we're getting started here. Your code needs to look like you cared. That's really what code readability means as we're going through here. So we'll go ahead and put a space here. Put a space here, and there's going to be other things that we're going to want to do to this file as we progress, but we just wanted to make it a little bit more readable, and we can do this in just a few more steps. Anytime you have commented code in here as well, you can go ahead and remove that. There's no reason to have that. Anyhow, so right now we're going through the file, we're doing these minor changes. A lot of this will be syntax stuff. Some of it's important, right? We're using a let instead of a const. And there's hundreds of rules when it comes to this. And so what you'll end up picking up are these good conventions. These conventions that say, hey, what makes good clean code? Because that's really what a linter is there for what it can do in that aspect. And you'll pick these up just through habit, pure habit. Damn. So what we've done is now we have made our code just using the linter, and there's still some errors in here, and we'll talk about those in a later section, but we have been able to make our code much more readable, much more understandable, and to the latest standards in terms of just basic TS-lint things and linters to get going. So linters are here to stop those syntax mistakes. Linters are here to get you to code in a certain manner, in a cleaner manner, in a more readable manner, and they are the first step to writing cleaner, more maintainable code. This will be the more of the hard code. Like, this is the only tool. The rest of the stuff we're going to be talking about, this is stuff that you have to learn, that you have to implement. And one thing about linters, and in our case we're just using TS-lint, but one thing is that you have the ability to override rules because they're not absolutes, right? We don't live in a world of absolutes, but these always help to get you going. These always help to get you started, especially when you're just getting started to writing cleaner code, and especially in a JavaScript environment where this is kind of a newer idea when you're getting going and no one maybe has told you about it, which it's kind of occurred to me like this is where we should start. Today we're going to be talking about how we can define our variables and use them better to accomplish a couple objectives, right? We all want to be able to write software like a professional, and these are some of the items that you need to keep in mind when you're using variables, as well as defining names for variables. So what is that going to accomplish? We're going to have 3 objectives by the end of this course. You're going to write code that is more searchable, readable, and understandable. There's a lot of ubles there, but this is what our objective is here. and we're going to talk a little bit about how we're going to accomplish those objectives. Now, these are just some of them, but we're going to be diving into other things as well. We're going to talk about following language standards, limiting scope of variables. We're talking about creating new variables versus reusing them, eliminating magic numbers and magic strings and items like that in general. We're going to talk about naming variables. We'll spend a good portion of time talking about that, about choosing a name that describes what a variable does or what its purpose is, not how it does it. And then we're going to talk about what I call this relates to naming the variables, what I call the parent or significant other test. We'll dive into that in the code examples. And we're also going to talk about when we can use long names for variables and when versus short names, and some of the how we can incorporate that into our code and more. Some of the and more sections we're going to talk about is the practices that a lot of people do that we need to break, right? You're actually causing more harm than good, and those are some of the examples we're going to give. So I'm not one that really like looking at slides. I learn from the code. Let's go ahead and dive in. All right, so let's start with a couple different things here. Here we have a simple algorithm to return a factorial of a number. It's not important about the code. It's not important that's in JavaScript. But the important point here is there's a couple things that we can fix immediately with our variables. One, we can start following the language standards, right? This is something that's very simple and immediately going to be apparent. In JavaScript, for instance, you would never, ever have something in all caps unless you're dealing with a constant, and an actual constant, meaning it's not an object or an array that you're going to be modifying. But this is something that we need to keep in mind at the very least, because before we can get into the higher level things of, hey, we need to be able to understand how to write good variable names, is we have to just understand how to write variables. We have to write this to our standards. So we're going to use our camel case, lowercase camel case, which is the standard here, and go ahead and fix this. All right, the next thing that we need to start thinking about is, can we eliminate variables? The less variables, the better. And this is actually some code I wrote from like 3 years ago. So, don't think that, everyone writes bad code and we all improve as long as we put the effort into. But can we eliminate things? This is something that we need to start thinking about because it's rather important. And the less variables we have to maintain, the better. So in our example here, we can actually eliminate this count variable altogether. There's really no reason to have it. And you'll see here, okay, what are we doing with it? We're setting it to 0. Okay, can we eliminate it? Well, yeah, because number here, which is just a number, and this is TypeScript, right? And we're expected to return a number here, just to provide some context. But count's doing nothing. Count is doing absolutely nothing for what we need to do it here. Is it performing anything different than number? No. Then what we can do is we can just eliminate it. There's no shame in eliminating variables when needed. This is just clutter at the end of the day. You should, if you can, have as few variables as possible, because then there's less moving parts. There's less things that we have to keep track of. Now, we start looking here where we have another no at the end of the day. This is debatable, but in my opinion, num is not a descriptive enough word, and we probably shouldn't be reassigning the values either as we are going through here, as you can see, right? So we're modifying num, which is now going to break this for loop, but let's go ahead and create a variable that actually has a good name. Now, when we create a variable, we want to describe what it does or what it is, and not how it does it. A lot of times when people start getting descriptive, let me give you a very bad example of a variable name in this instance. Let total multiplications, and we'll initialize it to num. All right, total multiplications is technically true for a variable name, but it isn't what we need to do here, and it's not what we should want to do either. Yeah. So total multiplications is not a good name, and a better name is factorial total. Now, what is this? Well, it is the number that we are storing our factorials in, our total factorial. All right, now let's go ahead and set up here, and we can do it just like so. And now here will return our factorial total and not some random num that's coming in. Let's give another example of some bad variable names. All right, let's take a look at this function. All this function's supposed to do is return today's date. Now you'll see here we have this D, and this is a very simple function, but we have this D here, and we're creating it. Now, if we didn't know what this was, and we didn't know what this was, would we know what D is if we had a conversation? So earlier I talked about the parent or significant other test. So if I said to you, baby, what do you think variable D is, what would you say?
That don't be gross.
Okay, okay. Well, what would you say if we renamed it to, I said, hey, what do you think today's date as a variable would be?
Today's date.
Excellent. That is the significant other or parent test. You should be able to hand someone a piece of paper, and this is the title, really, at the end of the day, and it should be that readable when you get going. Let's go ahead and give some other examples. Let's give a few more examples of how we might refactor our code in a relatively clean project where we want to make it more readable and more understandable when it comes to our variable names. Here we have an algorithm that is going to take in some values, a double nested array, for when we last backed up some items. That's all we need to know about it. Now, the first thing that we can do is, what we're going to be returning back is are the file IDs that we want to update. But you might be thinking, hey, we're just returning file IDs. Another way that we could to make it a little bit better is, it's actually technically we only want the ones to update. So go ahead and make that more descriptive. It's now making this function more descriptive in the process, and you have an idea of what it is you're trying to accomplish. Let's go ahead and update this like so. All right, next, one thing I talked about in the intro was that there are times to use short variable names and there are times to use long variable names. Now, in here, when your scope is very short, meaning it's like a callback function, it's returning something, it is all right to be using short names, such as here. So we're having file IDs. All we're doing is sorting it. I personally will still do file ID, but this is an understandable situation, especially in TypeScript, where we might drop that F, put ID, and then maybe we add a type of file onto here, right? And then it's just as descriptive as before, but now we can eliminate a little bit of clutter. But in terms of short scopes of our variables, like so, this is completely fine if we wanted to shorten those a little bit. But one thing I would highly suggest is that you start using tools that are built into the language, where if you are going to iterate through an entire array, for instance, there's no reason to do a for loop like this. We're iterating through the entire array, and we have tools to make this more descriptive while still iterating through it. So let's use a for of loop, for instance, and I'll talk about how we're going to make it more descriptive. So in our for of loop, we're going to remove some variables. We're going to remove all these ugly i's, and instead we're going to replace changes I with a more descriptive word that allows us to write cleaner, more readable, searchable, and maintainable code. So how can we do this? Well, what we're going to have is a change of changes, and we could maybe let's just refactor this one piece at a time. So here we're now eliminating pieces of text here, piece by piece by piece, and it's a little bit cleaner. Now, what are we iterating through? Well, we're clearly iterating through our array of changes, which is an excellent name. And when you were talking about renaming variables, make sure that you take into consideration renaming functions and renaming parameters, because they are equally as important when you're moving forward. And we'll have a whole section on functions and parameters as well. But that's neither here nor there. But you'll notice that we have this change 0 and change 1 and change 1. And, you know, if you're super familiar with the changes array, it may make sense. But we want to look at our code and not have to dive deeper. We want to have the simplest ways that we can do that. And we can use things in JavaScript and other languages as well, where we can give a more descriptive variable name and assignments here while making our code. So what is change 0? Change 0 is greater than last backup time. That doesn't make anything. But if we go ahead and create a const here, and we say, hey, let's do we'll say const is equal to, what do we want to do? Change we'll create a variable here. So each one of these changes are an array, and we'll do a little bit of array deconstruction, and we'll say last updated time, and we'll go ahead and also create a variable here called file ID, or updated file ID, and we'll just set this equal to change. And we have those variables. Now that we have this, we can make our code here so much more readable. Where we're saying, hey, oops, was our last updated time greater than the last backup time? That makes more sense than change 0, right? And was our updated file ID, do we already have, does our file IDs to update already include the updated file ID? If it doesn't, go ahead and add 2 file IDs to update our current file ID. Now, with just a couple changes in our logic here, not changes in our logic, changes in our structure, we have eliminated some of the floating, not floating, but index values that aren't needed, and we have instead done a little bit of array deconstructing to pass in values, and now this reads very, very clear, at least in when it talks about our variable definements. Definements was a weird word to use. One thing I wanted to say is don't be afraid to change variable names as well. So the thing you have to remember when you're writing code is that it's always changing, right? New features are coming out, updates are coming out, and even just sitting here, I was thinking about this variable name a little bit, and I was going to move on to the next section, but I was thinking, this isn't even completely correct. It's not that file IDs we want to update. We want to back up files. That's what we're trying to get here. Now, we are storing file IDs in there, but what is it we're trying to accomplish? We are trying to back up files. And so file IDs to back up. We're not trying to update anything. And so these are the IDs to back it up. So don't be afraid to jump in and change this. And if you dive into the code and the variable names are bad, or the variable names have slightly changed, don't be afraid to go and change it. A lot of times people are, especially if it's code they didn't originally write. One thing that people do all the time, especially when they're getting started with object-oriented programming, is they start prefixing property names with the name of the class. And it's a really bad item. What I mean by that is, say we have this cat class, and it is our friend's cat. That's whose cat it is. And we want to update our friend's cat's age, so they just had a birthday. You would have properties, which essentially are variables at the end of the day of an object, say, hey, cat age is now 10. And then our friend's cat dot name, we're updating his name to be Tito. We do not need to prefix property names in our classes, so we can go ahead and just remove that like so. This is something that people do all the time. And I've been guilty of this as well, so don't think most of the things that I'm telling you are things that I've done and learned from. There's no reason to prefix these items. We have IntelliSense, we can hover over, we can see the type, we can look through the code. All it does is create clutter and confusion. So when you're dealing with objects, you don't want to be doing that. Another thing to keep in mind is when you have constants, when you have variables, older developers, although it's not too common nowadays, will use what's called Hungarian notation, where essentially you're going to include the type in your item. So let's say we have a type here, and I remember our file IDs. So we do file IDs, and then you would include number at the end or at the beginning, depending on the convention. But this is essentially Hungarian notation. Now, this is a very bad practice and something that I encourage you not to do. For one, if you're using TypeScript, you don't need to. And most programming languages that is not JavaScript will have a type that you can assign to it. And two, what else could file IDs be? It could be a string, I guess. It could be a number, but this adds clutter and unnecessary, and it could be multiple things. So what if file IDs is actually a dynamic type, and so what do we get, a number and string, and sometimes it's a string number? What do? All we're doing is adding confusion to our code, so it's avoid Hungarian notation as much as possible. All right, one thing that you need to avoid as well are what we call magic numbers and strings for that matter. When you are, but that's a little bit different. Magic strings refers to passing in a key into an object that you haven't defined. You typically want to avoid that, but here magic numbers refers to passing in numbers that apparently came out of nowhere with no context, right? So here you'll see 63,667 and 0.4447. Do you know what this is? I do, just because I had recently looked at it, but it took me a second to figure it out. This is actually the Earth radius to figure out the orbital period. So let's go ahead and provide context, and we'll make this a big old constant in this case, in all caps, and we're going to set it equal to this value. Now we have a much better idea what this is, and we can go ahead and pass in Earth radius. Actually, I don't really like that. We're gonna do it like this. If I was doing a global constant, I might have it like that. But either way, so we have Earth radius here, and then what is this big old number? Well, it's going to be the gravitational metric. We'll do grav metric and set it equal to this, and insert grav metric here. Now our code is much more readable. We do have more variables, that's all right, but it's more readable, which is the objective here. So avoid magic numbers when at all possible. Another thing to keep in mind when working with variables is you want to limit the scope to be as small as possible. And what I mean by that is, here we have this beginner project that we'll be refactoring, or we did refactor in an upcoming linter video. But we have a ton of global variables. Typically you want to avoid global variables if at all possible. And when you can, such as like this answer button is used in toSpot, it's used in this function here. Same thing with only used in this function. Same thing I would imagine with this one and with this one. So what we can do is we can go ahead and take this, jump down to here, and put it into our where it belongs, which is in a more local scope to where it's at. The idea here with your variables is you want to keep them as close to where they need to exist, because it's going to provide the most context for how much they are useful, right? So you typically want to avoid the global scope if you can, and put variables in the most limited scope possible so that you can get that additional context. Another variable naming to consider is when working with Booleans specifically, there is a is for present tense or has for past tense in terms of the naming convention. This sort of lets you flag it out here, and we can, typically we don't ever want to put the variable types in here if we can avoid it. So we could do something like this, where instead of is box Boolean, we is box, meaning it is a box or it is not a box, or if you prefer the past tense, has box or does not have box in that sense. The only thing I will say that when you are naming this, keep it singular, because part of our objective here is to make items readable and pronounceable. So isBox would be how I would go about it typically for me in the present tense. So we can go ahead and replace box Boolean with isBox everywhere and clean that up a little bit. So that's something to keep in mind when working with naming for Boolean variables. Now this is a little bit of a personal preference, I would say, but one thing for variables is default parameters. A lot of times you'll see people use this, or if we have a invalid value here, a falsy value. But I would argue that if you need a default value for your parameters, they should be, which essentially are variables at the end of the day, right? We're passing data. Anything that passes data, we're considering a variable at this point. But we instead want to have this value here. The reason for it is it's its default value, thus you can assign it. The only caveat to that is that it works slightly different than our OR operator. So this will only assign a default value if it is actually undefined, while here it'll do it for any falsy value. So keep that in mind. But in general, you want to, unless you have a good reason, want to put it in your default parameters, because it's in one location, one place to look at, and it's in my opinion a little bit cleaner than using the OR operator. We're talking about functions. Our objectives for functions are going to be pretty similar to what our objectives for variables. We want to have readable, searchable, and understandable code, which will lead to more maintainable code. We could go ahead and put that in there as well if we wanted to, but 3 ubbles seemed like enough. So how are some of the ways that we're going to accomplish this? That's where it's going to differ slightly. We're going to write smaller functions, and we're going to showcase how we might do that and why and when we might do that. And we are going to also, let's go ahead and hide me for a second. Ooh, we're going to move Dylan. No, move Dylan. Dylan doesn't want to move. There we go. We're going to move Dylan over here. And what we're going to do is we're going to eliminate Boolean flags. We're going to talk a little bit about all these things. We're going to talk about why. I just want to tell you why to do things. This is the right way. Do it my way. It's not always my way, but do it. But I'm going to tell you why. That's important. So we're going to talk about writing our functions so they read top to bottom and making sure that's the correct way. We're going to talk about correct function naming. How do we know we're naming functions right? We're going to go over about 3-4 things that we can do to name our functions properly and give some examples. We're going to talk about limiting parameters and how we might go about doing that and why we need to do that. We're going to, of course, talk about the dry principle, which hopefully everyone's familiar with. Don't repeat yourself and why that's so important. We're going to talk about avoiding side effects in our code to the best of our ability, and we're going to be talking about why there should never be global functions. These are some of the topics we're going to hit on. Let's go ahead and dive into some of the examples. This file might look somewhat familiar, and we're going to continue to refactor it. So we've talked about one concept per, or at least I think we have one concept per action item, right? So if you were going to get some data, you might preface that with the verb get. You're not going to start using interchangeable words like retrieve and uplift, or I don't know why you want to say uplift. Typically you'd say get, and that's the idea here. And that goes the same for like if you're going to use the word update for updating something, that would be what you would do. You wouldn't say set, you wouldn't say update. You would choose a verb to stick with because you want your code to be readable. And part of that process is renaming the function names, as well as in the process eliminating comments. Now, in a future section we're going to talk about comments, but right now we're not going to worry too much about it because this is more about functions, but they kind of are interchangeable at times. So we have random number here. For the most part, this is a decent variable name. Some things that we could change about it is variable names are supposed to be verbs. They are actions that are happening. So how do we change this to a verb? Well, we add get on here. It's more descriptive of what it actually is. You'll see here we have a min and a max. We could maybe change random number here to be get random number from range if we really wanted to be specific. I think that's fine because that's as descriptive as we can probably get. And this is TypeScript. In JavaScript, typically, you don't have return types. This is a personal preference, I will say. What I think makes more maintainable code is when we actually put explicit return types. TypeScript is optional, and in JavaScript, it doesn't exist. But in most languages, you have the ability to add an explicit return type, as well as explicitly saying what these values will be, which I think is equally important. You know what? I think let's just go through this project from the top to bottom and see if there's a way that we can update these functions just to make the function names a little bit more readable, a little bit more understandable. Let's see here. So this is our box sizing prop. Add CSS to selected buttons and changes answers and box sizing. So realistically, I think this should probably be broken out into different different functions. Whenever I see an if else like this, I start thinking about how can I eliminate it. Not because if and else statements are inherently bad or anything like that. But usually it's because they really are doing two separate things, and I want to treat it that way. So in this instance, I would define a function update. Let's see, we're gonna update is box. So select changes answers and box says update border box sizing, something like that. And in here, let's start. It looks like we're not actually returning anything, which is why it's an update, but we can go ahead and put a void return type. And instead, let's start by here, passing this in here. That should all still be the same. And then in here, and I think we'll do a little bit more updating in a second as well. This dot update border box sizing. Else, this is going to be content box function update content box sizing. It looks like we're not going to be taking anything else in here. Go ahead and put a void on that, and we're going to go ahead and paste this in here like so, and go ahead and do this dot update content box sizing. Oh, I'm sorry, we don't need this on here because we're not working within a class. It's just a generic TypeScript application. So we've now put all the logic in two separate files, and we're saying at the end of here reset. So we have this dot border box and our else, and we've sort of put these into smaller functions. That's really one of the things. If your function's more than 10 lines long, you need to start reconsidering how we might be able to go about and refactor that. And you know that includes renaming these to provide additional context. Like we could probably have guessed based off the content that was in here that, hey, if border box is true, update border box sizing. And then reading through here to see, oh, well, we're updating content box, right? And that's how we did it to name this. But a better way of doing that is to write cleaner, more maintainable code. Is we can, and then that way also we can test these functions individually as well. We'll say, hey, update content box sizing. That makes sense. And update border box sizing. It's a more descriptive variable name, and it's easier to read here as well. And what happens on top of that, I guess, is that once you know, if any of the code's breaking, you're obviously going to look at these functions. But when you're looking at this sort of container, this public function meaning the user's going to be dealing with it, while these would probably be private functions, meaning that the user doesn't even know they exist. They just see that there's something that says update border box sizing, update content box sizing. They can't actually call these directly. Then we have we really only have to maintain one function and be able to read one function to see what it does in the meantime, unless something breaks or isn't working properly. Okay, so this would be a great example of how we might modify a name here. So we have this add points where we're incrementing points, and you could make the argument that perhaps what we're actually doing here is updating the points. Add is a little bit more descriptive, but update points by 1 by I. So this is a unique one because it looks like we're always incrementing. So you might actually be able to say that, hey, when we're always incrementing, add is a good name. So I take it back. I think this is a good value here. And then we are calling great job after the fact. Now this is more of a formatting thing, and we'll do a formatting video, but typically you want, and we'll leave it, but typically you're going to want to set your lot. You want to separate blocks of code based off spaces. Let's see here. So this is probably a name that we would refactor very quickly, and the reason for it is great job isn't descriptive, right? It doesn't really provide any context. It is sort of a funny name in the fact that, like, oh, great job. What is this actually? Probably a completion animation. This would be something like trigger completion, something like that. Like you have animation probably on top of there. Here we are saying like, hey, you completed it, it's an animation, and this triggers it, right? So this is much more descriptive than great job. Let's see if we have any more great jobs out there. Nope, just the one in here. All right, so cool. So we're triggering our completion animation. And I may have this slightly wrong, but triggering animation is right. There may be a trigger add points animation. That might even be something that makes sense. We're now adding points. I'm making the assumption that, hey, this is something that is is after they're completed the example. Let's see here, set styles. So I definitely would change this to update styles, because we are trying to do one concept, one verb per concept, right? And you also notice that good job was not a verb as well. Functions and methods, these are verbs, and we need to treat them as such, right? So I'm not really so here we're going to do update CSS display again, because we are updating a ton of different values here. Yeah, we'll leave it at that, I think. So answer buttons, a whole lot going on in this thing. Let me take a quicker look real quick. All right, so this is another great example of how we're going to set different values here. There's a lot going on in this function here. And to be honest, I'm not fully sure everything that's going on here. We're going to delete this line of code because that doesn't do dick. Alright, so it sounds like this is updating the answer button. So we're going to update answer. And there's, I mean, you could abbreviate BTN, but there's really no reason to. Don't be afraid to have long variable names. Long variable names are descriptive variable names typically. We have 3 things here. You know, we all use IntelliSense. It doesn't matter that we're using extra buttons. These are all great things. So how would we? So I think what we're going to do here is we're going to. Is incorrect one ever used? Yeah, incorrect one, correct one, then correct. So CSS is a global function. So I'm going to, and notice by the way how when I'm writing these additional functions that we're going to break out our code, it's always right next to it. It's by convenience, but it's also by design, where we want functions that are used by other functions, if possible, to be nested in the code where you would expect them to be, right? So I'm defining a function that I'm going to use here, and I want it to be nearby so I can see it and provide context. So in this case, we're going to write a get, and this is going to be get all answers. And this is going to take in, what is this taking in? Is this taking in anything? It is going to take in a nothing. It's actually going to just return things. So here we're going to return an array of, I believe, numbers. Cool. And what we're going to do is we're going to take pretty much all of this, and we're going to replace it with a const answers is equal to, and then we'll say the get all answers. And in here, we're just going to go ahead and return this like so. And what's the problem here? Oh yeah, let's go ahead and put this in here. Very nice. Okay, so I'm not worried about formatting and spacing. That's why I'm not cleaning this up for some of you who are losing their mind. It's, what I'm worried about is cleaning up our function code. So now we've put this all in one function where we're going to handle that, and then the thing that he thought was sorting the answer buttons wasn't. So we might as well just delete this code while we're at it. Oh. That comment's not relevant. Oh, I'll leave that in there for the comment video. Okay, so for each button.html, and even something like this, This is actually, so here we're updating answer buttons. I guess this is part of this one. We could break this out if we wanted to, but I think that's fine. But now we've been able to take a lot of this logic, slightly change it, and do something with it that now makes sense, right? We don't really need it all in here. This is getting all the answers incorrect and correct. If we wanted to make it more descriptive, we could even put incorrect and correct, because that's what I felt necessary to describe, right? So start going off your own thing. It's like, what does this do? It gets all the answers. What is all? It's incorrect and correct. So maybe if I usually go with the verbal test for a lot of things, and it helps a lot when describing functions. Yeah, one other thing we talked about was eliminating Boolean flags, and that's sort of what I meant with this if else, because that's really what it is. It's a typically a Boolean flag would be passed in here, but in our application, one thing that we could do is we could probably eliminate this function altogether and just do our best to have these trigger the correct code. And we could go ahead and throw reset into each one of these when they're called, and we can just say, hey, we need to make sure that this is only on the one with the ID of border box. And now we don't have to have this sort of Boolean flag, this if else that goes in there, or a flag that goes into the event or the parameter or anything like that. So typically, if you can, and it's not always possible, but it's possible more often than people think, it's great to try and eliminate those Boolean flags so that you don't have to worry about them. Now, somehow this is not. I think I talked about it when it comes to variables, about not having globals. But so in this project, we have this CSS here, which is we don't even really do anything with it. We just initialize it. So we want to do our best to not have globals, and there's quite a bit of globals in here. And the reason for that is even an object-oriented program, we want to have as few side effects as possible. It's not always possible. This. So you'll see this like CSS global variable here. Honestly, when it's like this, are we even? Let me see if we're even using this anywhere. Yeah, we are. We're initializing values. But you'd probably be better off doing something like this, where let's just eliminate this variable altogether. And in here, we are going to get the width, the padding, the margin. And so we can eliminate this global variable by writing a function where we say something, get CSS box model properties. And in here, we will go ahead and take all this and put this in here. And what we're going to return is just an array of those values, right? A width, the pad, the BRDR, the God, I would probably rename a lot of this stuff. So I'm going to guess this is border. I'm also going to guess that this is margin. And I'm going to guess that this is border style. So I start by renaming those, even though this isn't about variable rename, it's just as important. Margin and then border style. All right. So that's what I'm going to return here, which is width, pad, margin, border. We don't care about that right now. Other places where we're going to use this, we're going to update it down below. So in this instance, we are going to say const, and I think what we'll do is we'll just do some array deconstructing here, and we'll say this is equal to get CSS box model properties. That's a const. All right, cool. What's the issue here? Shadowed. There we go. I think width might be some sort of global variable, or might be a reserved keyword. Same with border. No shadow. Oh, maybe they want us to use it. No, we're using width. So pad, it should be padding. I don't like pad either. All right, so here for padding, we'll go ahead and throw it in like so. For border, go ahead and throw it in like so. Shadow, what is a shadow name? No shadowed variable. Is it not like that? I don't know. I think there's probably some naming thing in here, but instead of focusing on that on the video, you just focus on the idea here. So I'm just gonna throw a 1 on this. So we're just gonna do some string interpolation here. We're gonna throw margin 1. Oops. And then we'll go ahead and do border style 1 for. Oh, this is not border style. This is box sizing. See. Box sizing 1, and we'll go ahead and do that. And then down here, let's update our stuff. Box sizing. Excellent. And this is giving us the same thing here. I don't know. I have to look into this shadow variable thing is, but okay. Now, now we've gone and created this item here, and where we're going to be using those CSS properties. Let's go ahead and find the CSS here. Here, we can go and say const CSS is equal to get CSS box model properties, like so. We still have access to them. We've eliminated a global variable, and in our functions, we've eliminated side effects throughout the entire application, where we have to track, like, okay, I set the CSS property here, and now I called 5 functions. It's this after this step, this after this step. It got updated here, it got reverted here. We don't want side effects like that. We want to, even in object-oriented programming, take a somewhat functional approach and eliminate side effects. Today we're going to be talking about comments. Comments are a little bit of an interesting topic compared to the other items, because in this section there's more why we don't use comments than how to write good comments. But those are going to be our 2 main objectives. So we're going to be talking about what are good comments, what are bad comments, and how we can know if it's worth having one, what are some of the downsides of having them, and how we can, for the most part, remove comments and why, right? So the very first aspect that we're going to be talking about are what makes comments bad. This is just 2 points. There's a lot of other things, but this is the first example we're going to get. So these are the 2 most common reasons I would say that comments are used. That the major issue with comments, these main 2, and then there's about 5 others we're going to cover in a second, but comments are used when they really aren't needed, and typically comments are used to explain bad code. Usually when you are writing your code, at this point you've seen, good variable names, and we're going to showcase an example of that. Good function names, we're going to showcase an example of that as well. That if you write your code well in a descriptive fashion, you shouldn't really ever need comments. So let's go ahead and jump into an example. So we want to focus on 2 things in here. 1, where there's unneeded comments, and 2, where comments are unnecessary, right? And I didn't even talk about this in the slide, but misleading comments as well. One of the reasons you don't want to leave comments is that's another additional thing that we have to update, another thing that we have to maintain. It's documentation, essentially, that we have to maintain, and it could be counterproductive to our code. So let's look at an example of that first, where we have a function name here called longest string. It's singular. At one point, perhaps this returned the single longest string. However, examining the code and reading the comment here, it says gets all the longest string. So our comment here is different than the function variable name, and one thing that we can do to eliminate this comment is we can actually update this name to make more sense, right? So typically your function names just want to be verbs, and in this case we're getting an array of things, so we're going to get the long string. So we can eliminate this comment, and now we have a much more descriptive name. And these are things we already talked about. But here, our next comment is a example of just a length of what, right? So here we're initializing the longest let to index at 0, right? So this comment doesn't make a lot of sense. It's really unnecessary, right? So instead of length, we can call this, because let's look at how it's utilized. Here we're checking to see what the longest word length is in the string, and so we can do something like this: longest word length. Easy enough. Now we've eliminated that comment. We have one less line of code, and we have a much more descriptive word. And in this case, we don't really need to put, I've said in this case like 8 times, but there's no reason to define that, hey, we're getting the 0. That comment basically said we're initializing it to a length of 0. Does that help anybody? Can no one tell that that's what's happening here? It's very, you just have to read the one line of code and it's there. Adding that provides no additional value. So we now can go ahead and put this into here. We've eliminated our comments. And here's another great example of a comment that really isn't necessary. Checks if the current string is longer. Well, I think we can all tell that the current string is, in fact, like, this is what's going on here. This isn't an overly convoluted if statement. This isn't anything that's outside of the norm. We're doing a simple single comparison. And this comment here as well filters out any values not equal to the longest string. We can tell that this is essentially a one line, and even we could remove some characters here as well just to clean it up if we wanted. This is a one line callback function here that's filtering out. Now, one thing that we can do as well is to just hone this in is rename our variable here, and we can call this longest words. And what we've done now is we've eliminated some misleading comments, technically the comment wasn't misleading, but the function name was misleading, but typically it's in the reverse order. We've also eliminated unneeded comments just by renaming our variables, and just comments that really weren't doing anything, right? Hey, here we're telling it to check the length. Like, we can see that very easily. Two more things that people love to leave in that are really bad comments are leftover code. That's code that we've commented out and then that we don't plan on using at that time. And then version control code. So let's go ahead and give some examples. Now, this doesn't happen too often anymore, but occasionally some developers will have this bad habit left over when version control was a little bit more of an issue. And both these sections, I'm kind of combining the two because I think they stem from a place where version control was kind of a pain to work with. So you have these blocks of code here where the whole it's a log. They're basically logs. Hey, on the 4th of July, you put a comment in, and then, on the 10th, we put in, a comment here. All this stuff is handled in the version control with our comments, and there's really no point or place for it in it. Now, the other thing that is really bad practice is having, you can comment code out when you're working, when you're testing, when you're going things, but you should never have code commented out in your application when it's in production or it's moving forward. The reason for it is you're going to confuse future developers. Why is this commented out? Is this supposed to be commented in? Should I go and delete it? If you're no longer using a piece of code, delete it. If you need to go back and get it, that's what version control is for. We have references to it. There's tons of logs that have all this sort of stuff. We can jump back in and get it. There's absolutely no reason in today's world to have commented code in your production application. So I'm commenting back in because this is part of one of my actual projects, but delete it from the application and move on with your programming. So visual markers are another really bad tendency when it comes to comments. So what's a visual marker? Essentially just a block of code, of a commented out code to say, this is what is here. This is what is there. Let's go ahead and give an example. So I know we've all seen at least one file in our lifetime that has done this, where you have these sort of blocks of codes that really describes what's going on with the structure of your page, what's going on with the formatting of the page here. Dependencies are here, meta information here, properties are here, public functions are here. Really, when it comes to structuring of, and this is Angular, but this is the same for any sort of class or any sort of component or just code in general, you want to, this is much like other comments, just filler text that takes up space and room. And if you actually think that you need to break out this part of your code, you need to consider having a new file, because the concern is so different that you need to put a big block like this. Then maybe it is something that's entirely different, and we need to pull that out and give it its own sort of domain. But there's no reason to have these tags. Let the structure of your classes be what they should be, right? So properties are an excellent example. Typically, your properties would be the first thing in your class, and followed by maybe a constructor and then a function. No real need to put self-explanatory sort of tags like, yeah, this is clearly the decorator meta information. This is clearly the dependencies, which come up at top by standard. So these sort of visual cues, visual markers, there is absolutely no reason to have it in your application. The last sort of item I want to sort of caution you when it comes to comments are to-dos. So if you're not familiar with to-dos are something devs like to do where they like to, I'm trying to think of a different word than do, but they like to do to-dos to say, hey, go back and add this feature, expand upon this, remove this, delete this. And I don't really have any examples to show you for this, but I just want you to understand why it's bad convention. For one, a to-do, much like other comments, are something you have to maintain. It's something that you have to keep track of. Now, if you want to keep track outside of the application, that's perfectly fine. But requirements change, which means that to-do may no longer be a to-do, and you may not be the one doing it. But if someone sees it in the code, they may do it, and it may no longer be relevant. And in fact, it may actually break the code. It's just another thing we have to maintain that can cause confusion and issues down the road. So please avoid to-dos. So we've talked about some pretty much a ton of bad comments, and if you've kind of got a feeling from this that you shouldn't leave comments, in general, that's a good practice, right? We've talked about how we could eliminate the need for comments, because comments are really there when we have failed to name our functions and our variables properly, and in our code to be descriptive, right? We want to better structure our code so that we can tell what's going on in the code without having to leave the comment. That's our objective here. We're going to write better code where comments are not needed. Now, there are some times where comments are especially needed, and we're going to give some examples of what those might be. So let's talk about the characteristic of some good comments and some comments that we have to have. So the first thing is that it needs to be short and concise. It's whenever you see a paragraph of commented out something, chances are a lot of that's fluff, a lot of it's unneeded, or it's redundant, and it's going to cause more issues and with such a big comment, it makes it even harder to maintain. So we want to make it short and concise, right? If it goes longer than one line, you've messed up on your comments, so you need to refactor it. It provides value. Just saying, hey, constructor here, we can see a constructor's there, but what's the value? And so when do we use a comment, right? So these next two things are grouped together, but we use a comment when it clarifies code that has a business purpose but looks out of sort, right? So what I mean by that is there may be some domain knowledge in the system that newer developers may not be familiar with, and here we say a warning or an amplification of its importance to say, hey, I know this looks strange, and it's there's not a cleaner way of doing this, but we have to do this to protect ourselves, or we have to do this to provide the functionality that's needed, and here is why. So when there's something that's strange like that, like, oh, I don't think we have to do this, but we actually do, that's where we want to have a comment comment for that business purpose, as well as to provide a warning or the amplification of its importance. And then, of course, legal comments. Legal comments, there's no real way around it. Sometimes when you're using open source libraries, you need to have a legal comment at the top of your file to use it. That's just something that's part of it. And there's other ones as well. Those are the types of good comments. So let's go ahead and give a couple examples of a warning or a amplification of importance type comment. All right, so let's take a look at some examples of what perhaps could be considered good comments. So the very first one is a legal comment. So as I mentioned, sometimes when you use open source libraries, they'll have you paste this into one of your pages where you're using it. And so these typically will go at the top. There's really nothing you can do to get around it if that's what the license says. In this, I'm just using random open source library. I just made something up and sort of what it would expect. So gotta have that. So I consider that a good comment, not the best comment. The next is an informative comment that isn't readily apparent, right? So something that showcases but needs clarification. And there's not really a good way when we have these three different date matchings to, in the variable, do it without it getting clustered and cluttered, and it's just not going to look all that good. So here we say, hey, this regular expression, its expected format is these three items. Now, or are these three items, rather, these three formats. And so that's a great way of doing it. Now, there could be an argument made that perhaps we could see this in a test for wherever we use this function, and that's a fair argument. But this is an example of something that I might leave a comment to provide value. Because, I mean, at first glance, I don't think anybody's going to look at this and be like, oh, yeah, this is what it does. No, it's not like, nothing like that. So another thing is, remember when I told you about warnings or amplifications? This is an example, right? So let's say we're taking in an ID, and this might look a little strange to you when we're comparing these numbers, that we're trimming the value that comes in and we're parsing as an int, all this sort of stuff. So perhaps what we, and probably want to do that for JavaScript, but say there was an outstanding issue, and even this is the best I could come up with off the top of my head, but we're trying to explain why we're removing the trim from the string. And the reason for it is there's an outstanding issue where the UI layer is injecting characters, and perhaps we can't solve it, or it's something in there, but it's a warning to say, hey, why are we doing this, and why are we treating it as a string and all this sort of stuff, and why are we trimming the characters? It shouldn't be passing any empty characters with it if we did our job right? So those sort of warnings as to, hey, this doesn't really make sense, this is kind of odd, those are the comments that you have to leave for when there's no way around it, when there's something that you need to tell them, like, if you remove this trim, I know it looks like it doesn't need to be here, but if you remove it, it's going to break everything. And we haven't found a way to fix it yet, or we're going to fix it. But short and concise, provides value of some sort, telling you what it is, and then legal comments. Now, by the end of this, you've probably said, hey, man, so we don't leave comments anymore. That's a good thing. That's another thing we don't have to maintain. Our unit tests are going to be our form of documentation to explain how our application evolves. Our code structure should be clean and concise and follow standards, and that there's no reason for those blocks of codes. Comments for what a function does or a variable is should be far and few between, because we're going to name our variables properly and we're going to name our functions properly so that they're descriptive and show us what our code is doing instead of us talking us through. Comments typically are used as they're redundant, and they're used to tell you what you can already see. But worst of all, they are a crutch for bad code. And so we're going to make our code better so we don't need comments. If you've never heard the SOLID acronym, or you're not familiar with it, don't worry. We're going to get you caught up to speed. So what are the SOLID principles? Well, as I mentioned, it is an acronym. And the S stands for the single responsibility principle. The O is for the open-close principle. The L is the Liskov substitution principle. The I, which is one of my more favorite principles of the SOLID principles, is the interface segregation principle. And finally, we have the dependency inversion principle. So there's a lot of principles going on here, 5, right? Somewhat intertwined, some of them. All of them are important, and we're going to dive into a little bit about the history of the solid principles. So where, or who rather, did these principles come from? Where did solid come from, right? Because these things don't just come from nowhere. And they came from Robert C. Martin, who you might more affectionately know him as Uncle Bob, who is the author of Clean Code, the Clean Coder, and Clean Architecture, which if you haven't read the Clean Code, the Clean Coder, regardless of what skill level you're at, whether you're a super senior or you just got started today, I highly recommend those books. And Clean Architecture I recommend as well, but I think you should wait till you probably have at least a junior level role. And there's links for all that in the description below if you're interested. But with that being said, he introduced it in a paper in 2000, about almost 20 years ago, on the design principles and design patterns. And that is really what the solid principles are. They're ways for us to write our code and deliver some things. And we're going to talk about why we should write our code in such ways so that they support certain development practices. Now, he's also the co-author of the Agile Manifesto. And you might be saying, well, why is that relevant? Well, because that's part of the solid principles goals. If you've been working in software development for the last 10 years or so, what you've probably seen is that the waterfall software development life cycles are dry and dead, and Agile is a flowing river, if you will. And so that is what we're trying to accomplish with the solid principles. Is in general, I would say that they are designed for object-oriented programming, but that you can use them with other like functional stuff. But it's most performance, not the right word, but I'd say it aligns best with object-oriented programming. I would also say that it's language agnostic. This isn't something that you just do for Java. This isn't just something that you do for JavaScript or C# or your language of choice, Go, whatever, Rust, whatever it is. And that's one of the great things about it. And it also supports Agile. So as I mentioned, Agile is sort of the way of of software development nowadays. And because of that rapid development life cycle, that if you're doing Scrum, you have 2-week iterations where you're delivering features every 2 weeks, right? We have some places are doing continuous integration and continuous deployment, meaning when it goes out, it's out. Like, it goes straight to master. And so we need to make sure that our architecture is great, and we need to make sure that the testing and the test-driven development processes are followed, and these solid principles help us to do that. So why does it help us do that? Well, it helps us accomplish a couple things. It helps our code to be more understandable or readable. It helps it to be easier to maintain, and it allows it to be flexible. So the strengths of the solid principles is it abstracts some things, so when changes happen, it's much more flexible to get them to work, and it allows us to extend things instead of breaking things and having to rewrite things. And so that it's much easier to add something than to have to rewrite an entire thing. And that's one of the strengths of the solid principles. And it accomplishes these 3 things through the 5 principles. All right, so let's go ahead and dive in a little bit to each one of these principles. So just give a high-level overview of what they're trying to accomplish. So the single responsibility principle. The famous quote, "A class should have one and only one reason to change." So this is about good organization of your code and understanding how good inheritance works, and understanding how to write our code in such a way that things are bite-sized to a degree and are not going to have more than it should, right? We'll give some code examples, but there's a lot of, and we've talked about this in other clean code series, where you don't really want to pass booleans in to tell it to do one thing or another. For instance, that could, depending on the situation, change the logic that's happening. Not if something should happen, but it's like, hey, do it if it's this person, don't, or do it if it's this other customer type. That might be something where now we have multiple responsibilities in a single class. We don't want to do stuff like that because it makes it much harder down the road to follow the logic, to follow the code. But it's all about keeping things into the bare bones minimum that a certain object should do, and enforcing that with the single responsibility principle. So we, after the S comes the O. Open-close principles. You should be able to extend a class behavior without modifying it. So this goes to my earlier statements about we want to extend functionality. We don't want to modify functionality. And, principles are in a perfect world, right? Sometimes requirements don't come through, and sometimes this isn't possible, but this is the general idea. These are what we are trying to follow in a perfect world. And so another item about this is you want to be able to, if you're following proper inheritance, you should be able to swap in different versions of different services and items like that. So you can extend maybe an interface that will go in for your service or items like that. And the open-close principle refers to that. It'll make a little bit more sense with code. I did a very poor job explaining that. But essentially, we want to extend items without changing the code base, right? So if we're adding a new feature, in theory, we shouldn't really need to modify the previous code. And if we have written our code in such a way, we're going to add upon it instead of modifying what we already have. The Liskov substitution principle, and I don't know too much about the gentleman named Liskov, but he had some good insight here. So most of these principles are not necessarily Uncle Bob's ideas, but ideas that he has used and catered and somewhat tweaked and over the last 20 years or so put out there and that's sort of his goal, to get people, software developers, to write them. And Liskov is just one of the many people along the way that have he has learned from, I suppose is what I'm trying to say. So with that being said, derived classes must be substitutable for their base class. So in any good object-oriented programming language, you usually have a base class that you can extend to your child class. An example of this, an excellent example on Stack Overflow, if you were to look this up, is a square class extending from rectangle. So the reason that you wouldn't be able to essentially swap the base with their derived classes is because they function differently, right? At first thought, it may seem that, yeah, you know what? Why wouldn't they? Why wouldn't one inherit from the other, right? Every square is a rectangle, but not every rectangle is a square, and that should be your hint right there. Because if you can't swap them out, then there's something going on wrong here, and you might want to rethink your approach, right? Because let's say you change in rectangle or in a perfect square. You always want the length and height to be the same. So there might be logic in there that would handle that, but that's not necessarily the case for a rectangle, so you wouldn't necessarily swap them or inherit from one. And so those are the types of things you want to think about, because there's probably a better approach than inheriting from a class. And so this is what the Liskov substitution principle, derived classes must be, you must be able to substitute them for their base level classes. So the interface segregation principle, one of my favorite principles, I like a lot of them, but the clients should not be forced to depend on methods that they do not use. At first glance, this quote, I probably could have chosen a better quote, but the idea here is that you don't want to couple the code so tightly that you can't make a change without making changes in multiple places. And so to help facilitate that, we add a level of abstraction, which we do through interfaces, and this allows us to do a lot of things. Once it allows us to easily overwrite code if we need to, right? So like a common use that I use the interface segregation principle for is testing, right? So sometimes when you're testing on the front end, you might inject an interface, and it's going to, that your service extends, and then you can maybe mock it out or expect different things or override it. There's a whole bunch of different things that you can do with that. But the interface segregation principle is key to that, because if we were passing in the actual service call itself, it'd be very difficult and probably actually hit the API, so we don't want that either. But we'll dive more into that. But the idea here is that twofold. One, that you should have a layer of abstraction, and two, that you shouldn't force people to use things that then makes it so tightly coupled that that you can't override it. And that's the idea here with the interface segregation principle. Now, if you haven't noticed by now, I've said the word abstraction about 15 times. And in the dependency inversion principle, that will continue on. So high-level modules should not depend on low-level modules. Both should depend upon abstractions. This goes back to depending on, not necessarily interfaces, although you will, but depends on, instead of having your actual code depend on other aspects of your code, what you want are to have those abstraction layers that you code in there, and that allows a lot of flexibility, especially when it comes to testing and mocking things out. And so the dependency inversion principle helps support that as well. Today we're going to be talking about the first letter of the SOLID acronym, the S, the single responsibility principle. I will be your host as always, Dylan Israel. So what exactly is the idea behind the single responsibility principle? Well, it states that every software module should have one and only one reason to change. Now, what does that actually mean? It means that we're going to have smaller classes, we're going to have single responsibility classes, and this is going to allow us to limit the impact of change. So, what does this actually mean? So this is a quote from Uncle Bob, who is a very big proponent of the SOLID principles, essentially the creator. Gather together the things that change for the same reason, separate those things that change for different reason. So what I take that to mean is we're going to have cohesion where it matters, and we're going to decouple our code where it doesn't matter. Now, most people focus only on making things as small as possible to automatize things to such a degree, because that's more so the issue. More so people have things that are just too big, but you can also go in the opposite direction. You make things too minute and too small, and but that oftentimes doesn't get any attention. But I wanted to bring that up because that is an issue in itself. So let's go ahead and I want to share this link actually real quick before we jump into the code. But this is a link to Uncle Bob's blog where you can read more about the single responsibility principle here. And I think it's really helpful, so go ahead and check that out. I'll put it in the description below as well. But let's go ahead and see an implementation example of how we might use the single responsibility principle. All right, so let's take a very simple example here of how we are not using the single responsibility principle and how we can go ahead and use it to make it better. So I'm doing this in TypeScript. You can just think of it as JavaScript for the most part. Now, everyone should be somewhat familiar with the cash register, right? We have ways, they charge tax. It keeps track of our totals. There's a subtotal typically, and the grand total, which is your subtotal plus tax and any fees. So we have a very simple example here, and we have a function called calculate total. All calculate total does is it updates our grand total, so it gets the total with tax, and then we email a receipt to the client. Say, hey, thank you for your business. Your total was $100 if you're balling hard and you buy a lot of groceries or something. So you might be saying, why is this breaking the single responsibility principle? Well, should this private email receipt actually be sending anything in reality? And mind you, it's an empty method. Or should the cash register be worried about having logic to email a receipt? And the answer is no, it shouldn't. What should happen here is that there should probably be an email class or message class that handles this, that we then instantiate that class and have it go there. And the reason for that is it's still going to send an email, right? Because our mail class is going to handle that logic, but that's really where it should live, right? And that way, if we change our code down the road where, you know what, we need to update how we email clients, customers, it's all in one central location, and we now have a single reason to change. Right? Before, we had two reasons. We had, well, if the total changes, if the cash register code changes, great. It's right here. But also, if we want to change how we email customers and clients, we have to go into every class that we had this email logic, and we then have to modify it. Well, instead, if we had a central class that handled that, we can go ahead and do exactly that in one central location. So it makes our code a little bit smaller and puts it in different files. So how might we fix this? Well, pretty straightforward, right? We go ahead and create a new let's just call it email class.ts. We can go ahead and export a class here, and in here what we're gonna call this email. And email is going to have a message. And notice how before we had send receipt, this is more of a generic class where maybe it's going to be something like send message, right? So we'd have a public send message, and in our example, it just took in a message. This would be a string, and this would go and email, let's just say we pretend that we have something to send email. We'll console log the message. Whatever our logic here does, it doesn't really matter. And then we could simply go ahead and take what's here, and we're going to create in the constructor. We can create a property here, and we'll call this public email equals new, or public, God, maybe mail would have been a good name. Public email. So new equals a new email. New email. Just go ahead and import it from there. Oh, you know what'd be better actually? Let's just make that a static method, right? Because are we really ever going to create multiple versions of it? This is a little bit more of object oriented, but this is going to be a static send message. And now this is going to do the same thing every time, right? Similar, if you're not familiar with static, it essentially means that this is a property or a function on a class that you can use. You can import it once and use it, and it's not going to be something that you're ever going to necessarily redo. So here we have email.sendMessage, our static method, and we'll go ahead and just pass that message like so. And we can delete this logic here. And now we've set it up so that it has one reason to change. We're still sending an email with the receipt, but our cash register, the only reason our cash register changes is if something regarding the cash register domain changes. Well, now that we have this email class, if anything in our email class changes, then it'll auto update if in our cache register or anywhere else we're using that class, because it has a single purpose now. And so that's really what the single responsibility principle is trying to instill. A good rule of thumb when you're trying to decide what's what is if you find yourself having to put and or into your variable names and function names, you oftentimes will see that you probably don't have things broken down enough, and because of that, you're probably breaking the single responsibility principle. A good way to also help and so, sometimes developers will find themselves in this. Developers who aren't used to like maybe object-oriented programming will find themselves into a situation where they start doing like Boolean flags. That's another example a lot of times of, not always, but where you might, instead of perhaps extending a class or using some inheritance, you might be using a Boolean flag to change between two pieces of logic that do two completely different things. That's another sort of gotcha to watch out for when using the single responsibility principle. We're now on the open close principle. Let's go ahead and jump right in. So what is the general idea for the open close principle? Well, you've probably heard this if you've ever heard of the open close principle many times, but software should be open for extension but closed for modification. I'm using software very generally. We're talking about classes, we're talking about modules, pretty much any aspect of software that's reusable. We want to make it open to expand upon, but closed to modify that original level of code. So what does that really mean? Well, what it means is, this is my interpretation, but essentially means we want to extend the code so that we don't have to refactor legacy code. Legacy code being code that was there before we started writing our code, before we started expanding upon this. And this is especially helpful, not necessarily in greenfield development, but when you are adding new features to code or refactoring code. So what does this actually mean, right? What it actually means is the successful use of inheritance properly. You know, how we can extend things using inheritance makes it gives us some flexibility to make our code more, wait for it, solid. And it allows us to change our code easier and allow these changes to occur easily, so that we don't have to worry about it breaking and it being an issue to jump into the code, and we don't have to update it in multiple spots. And that's this last note here is a well-written class should not have to be updated in multiple spots. Now, again, these are principles. These are not the end-all, be-all. There's always exceptions to the rules or exceptions to the principles, but these are the general things that it will actually allow us to do. So let's go ahead and just make a quick note. Solid principles are, a lot of people have preached about them, but one person in particular is Uncle Bob, or Robert Martin, as you might know him. And his blog post here goes into greater detail on the open close principle. And I would highly encourage you to check it out just to have multiple interpretations of it. I'm going to give you my interpretation of it, and you can get someone who's much more familiar with it than myself, because he's been preaching about it for about 15-20 years. But that's a lot of words. Let's go ahead and give a live example. Now let's jump back into our previous example with the cash register. You'll notice here that I've added a constructor that's going to take a balance, and it's going to be a number, the balance of the drawer essentially. And so a bad example of how we would be modifying our code is exactly like this, right? And so we might have a balance property here, and we're going to assign that to a number, and it's somewhat relevant, right? So we're going to say like this dot balance is equal to the balance that comes in. But now what's happening is here, we're actually modifying the original code, and this will happen again and again as we continue to expand upon our cash register example. But you may be saying like, Dylan, well, shouldn't the balance be part of the cash register? And isn't going to need, subtotal tax rate, maybe the grand total, because we may have to, find out if we have enough cash in the drawer. But by modifying this, we're now adding complexity to the cash register that maybe what we really need to do is define a drawer class that extends the cash register, that inherits from that, and that's where the balance lives, because it's sort of new functionality that we can actually make it a little bit more, a little bit of a smaller class while still having access to that. So let's go ahead and do that, because that's going to show an example. Here we showed an example of what we don't want to do. We want it to be closed to modification. Well, how would we make this open for extension? All right, and to do that, let's go ahead and just create a little file here. And we'll call this drawer, cash drawer, if we want. And what we're going to do here is we're going to export this class here. I guess we don't technically have to export it, but we'll call it our cache drawer. Cache drawer. I don't know. Someone will correct me in the comments, I have no doubt. And in our constructor here, we'll go ahead and essentially do the same thing that we did. It's going to be a number. And we'll go ahead and have a property here, public balance. We'll make that a number, and then we'll set it. This dot number is equal to balance. Oh, this dot balance, excuse me. This dot balance is equal to balance. Cool. And now, let's go ahead and take this out of here because we don't want that in there because that would be extending it. But here, we just need to extend our original cache register. And when we're doing, at least in TypeScript, when we're extending a class, we need to call super, which is just essentially saying that this is a child or being extended from our cache register, which is the parent here. And now, although we have all the access to subtotal, tax rate, calculate total, but it has its own draw. We have our own drawer here where maybe we need to use some of those properties later on. We will. We can have access to that. We can reference them here and not have any issues. And we've successfully been able to extend the cache register class without actually modifying it. So open for extension, close for modification. Now this is just one example, and a very simple one at that, but these are the sort of things that you need to think about as you're developing code, right? What separates a junior developer from a senior developer is the ability to not only make the code run, but both of you will have your code running, but having something that is going to last the tests of time to the best of our ability, be easy and maintainable and testable to, and allows change in a much more simplistic fashion. So that's the open-close principle. Today we're going to be diving into the Liskov substitution principle, our third or fourth video on the solid principles as we're working our way through. And this one's a little bit of a doozy, if for lack of a better word. So I'm going to give you the very computer science heavy. And if you've ever gone and pursued a bachelor's in computer science or really looked into the fundamentals of it, this wording will seem very similar because a lot of these principles are worded in such a way. The idea from that stance is if S is a subtype of T, then objects of T may be replaced with objects of S without altering any of the desirable properties of the program. So this reminds me of college quite a bit, and it's a little bit confusing, right? It's even for people who write software professionally, there's probably a better way of explaining the concept that we can do that. So what does this actually mean? Well, what it essentially means is that subtypes should retain the behavior of the main type. Now we're talking about inheritance. And the easy way of putting that is children should be like their parents for what they inherit. If you are overriding the properties of the parent, then probably what should happen is you might want to rethink how you are abstracting your code and how you are inheriting your code and the structure of that, because you might have something wrong because it may not be a child, right? And a basic example is if I'm a human, April is a human, and that is our type, and we have children, and it's a duck, something went wrong because we should not be able to have a duck. It could still have a name property, it could still have an age, right? But it definitely should not be a duck. It should probably be a human child. No, it definitely should be a human child, and we have to rethink it. So the common thing that happens is, that's what that actually means. And the way that most people explain this to you is that if you cannot substitute a child class for its parent class and your code still be functional, then that means that you broke something that class is inheriting, because all your child class is doing should be extending the behavior. It should not be altering the behavior of a parent class, right? And so with that being said, let's go ahead and jump into an implementation of this, because it's a little computer science heavy, but we'll give a good example. As with all things software, Stack Overflow had an excellent example, I think, that really hammers the Liskov substitution principle down. So let's take a look at the code here. We have a rectangle class. A rectangle has a height and a width. They are independent of one another, right? The height can be any value and the width can be any value. Any positive value, I should say. And when we set the height with the method and we set the width, all it's doing is setting the height and the width. Now, one thing that people suffer with, and one thing that people get wrong about object-oriented programming, is they oftentimes say that it models real life. That is a fallacy. That is somebody who wants it to make sense. But you are taking the abstract and making it concrete. You're not taking the concrete and making it abstract, is how I kind of think of it. And although there are similarities, it is not always the case when it comes to code. And this is a great example as why. So we have our rectangle class and our square class as well, which extends rectangle. It inherits from it. It is a child of our of our rectangle class. And the issue here is when dealing with a square and a perfect square, your height and width are going to be the same thing. And you'll see here, we set the height, it's going to set the height and the width. We set the width, it's going to set the width and the height. And now, what ends up happening is anywhere we actually want to use this rectangle class, we are going to, if we were to swap the child with the parent, it no longer would be an accurate representation of what it is we're trying to accomplish. And because the parent class here cannot be substituted, although a rectangle it can still be a perfect square, it defeats all other rectangles, right? It's not that it's impractical. It's not that it doesn't really, from a logical standpoint, make sense that, hey, let's extend rectangle for our square, because that makes sense mathematically, but the practicality of it is that's going to break the substitution principle and cause issues down the road, because we should be able, based off the principle, pass in the child for the parent without any additional setbacks. So how might we solve this issue if we wanted to extend rectangle? Well, the honest answer is, one, you could remove it entirely, which we could do here. The other answer is we could maybe reorganize our code so that we have a shape class. And so perhaps we would, and this is just me sort of freeballing it, but perhaps we would create a new file called shape. We're going to export class shape. And in here, we might have a public type. And we can go ahead and make that a string. And that would maybe be enough. If we wanted some similarities, probably not what I would prefer to do, but perhaps all shapes will have a height and a width. And in here, this will also be a number. Oops. And from this, we'll have rectangle. We got that out. That extends shape. And we will have square that extends shape. And now we have a class that if we were to swap it in and out, it'd be fine. Now granted, it's a very basic class, and we don't even need type in its current iteration. But here, if we were to swap either one for the parent class, we shouldn't have any issue, right? We're not going to overwrite. Height and width are still going to be numbers. Take out the type. And that's all we're really checking for here. There aren't going to be any side effects. But in our previous example, we would have just fine by extending upon a rectangle because we can't substitute for them, hence the substitution principle. The Liskov substitution principle is one of the harder ones, in my opinion, because you almost have to have very real world working examples before you sort of run into this issue. We're going to be talking about the interface segregation principle in this episode of Code Like a Pro, the fourth principle of the solid principles. So what is the idea? Well, the idea is to not force the client. The client could be people consuming your class or your object, or other developers, right? So that could be third-party in-house. But to make it so that they are not forced to depend on methods they do not use. That's the idea. So what does that actually mean? Well, it supports what we've sort of been talking about, which is smaller classes or interfaces. This idea of role interfaces, which is essentially breaking out into the smaller classes and interfaces that should be defined, and we'll give an example of that. And this supports abstraction, because as a application continues to grow, we're going to start having these issues where I have to make one change in here and one change in there and one change over here to do this one change. And so if we start following the solid principles and the interface segregation principle, that abstraction will allow us to make those change in a much easier manner without having a lot of side effects, which is something we want to avoid. So how do we do it? Well, let's go ahead and give an example. So let's take this very large interface here, and typically a large interface or a large class is indicative of a very complex object, and you have to say, does this object need to be that complex? Does it really handle this? Is this everything I want to be? So just sort of a red flag. But you'll see here we have our vehicle interface, just defining what our vehicle class would be, right? We have a get speed that returns a number, a get vehicle type, which is going to be a string. Some financing things. Is tax paid? Are the lights on? Have we started the engine? Have we accelerated? Have we stopped the engine? A start radio. Have we? That should be a function. Do we want to play a CD? Do we want to stop the radio? So we have all these sorts of various properties of what a car or a vehicle might have. And looking at this is going to cause us a lot of problems, where every time we modify the vehicle class for any aspect, whether it's the engine or the music or the lights, whatever it may be, we're going to run into these issues where we are treating this vehicle object as one and the same, and the reality of the situation is that's not necessarily true. So how might we go ahead and fix this? Well, let's do a little bit of refactoring here, where instead of just the iVehicle, we can have maybe an iLights, right? So let's define an interface here called iLights, and in TypeScript you typically denote an interface with an I. Oftentimes I'll build a abstract class, because interfaces are just sort of and you can do a little bit some more complex interface stuff, but I don't want to get too much into TypeScript. But if we have lights, why wouldn't we have it is lights on and have that over here, and it'll be the same thing, right? It's just returning a boolean. So we go ahead and take that out, and is lights off. Excellent. And we could do another thing where let's go ahead and create a radio interface, right? Because we're playing with the music and the radio. And we would have our start, stop, and play CD. That's all of our radio object. And then of our iEngine, right? So let's see here. We have start, engine, accelerate. That all looks like to be an engine. We'll go ahead and do something like this. Oops. Interface iEngine. Excellent. And so now you'll see that we've sort of broken this out a little bit more, and we can reuse these as needed. And if we needed to, let's go ahead and actually say we had a vehicle class and we wanted to consume these things, right? The vehicle class is going to extend iVehicle like so. Let's go ahead and import that. Now I want to extend iVehicle. No, extends. There we go. No, extends. Implements? Do I need to save this? Is that why it's not finding it? There we go. So, and you'll see here that we need to implement some functions, right? We want to implement the get speed, the get vehicle type is tax played. So we can go ahead and define public get speed, and that'll do something. And we're gonna say public is tax payable. Right here for the time being. I'm just filling this out real quick. So we'll return that. Just return 2, 1, something like that. And we have 2 more implementations, and then we're going to actually use the other interfaces in a second here so that we can consume those in a more responsible manner if we felt that we needed to do that, right? So return this. Just put an empty string here for the time being. Oh, this is just a property. Excuse me. Just for the sake of time, we'll go ahead and make that a function. And then we'll go ahead and throw that on there as well. And we'll just return true. All right, so now we've been able to actually implement that in our vehicle class, but we might have other things that we want as well, where maybe we have a radio of type iRadio. Oops. And we have to export these as well. And then we'll go and we'll assign whatever properties this radio. I'd probably have a class in reality. But what this gives us the ability to now is that all our radio logic is now separated out over here. We have our various interfaces and we can use them, and it's all broken out to what it needs to be, right? And we've now separated out piece by piece so we don't have to, and abstracted it so that we don't have to rely on this massive vehicle interface or class for that matter. So, you know, it's a lot of these principles will sort of fall into that whole, that each sort of touch each other. Like some of this may feel very similar to single responsibility principle. And some of you may be saying like, well, why am I importing radio into the vehicle class? Well, you have to understand, let's say one of our developers wanted to use just a radio, right? They had a need for a radio class and we wanted to follow that. If it wasn't broken out like this, they would then be forced to install the vehicle class just to use the radio. And so what we're doing is we're going to abstract it, break it down a little bit so that you only care about the pieces that affect your development, that affect your code, and support good object-oriented principles. So as always, guys, I hope you found that helpful. Don't forget to comment, like, subscribe, and share. And look forward to our next video, the dependency inversion principle, which is by far one thing that I would say I didn't fully understand, but is by far my favorite solid principle, and I think has made my software, my code writing, taken to the next level. So I really hope you take particular interest in the dependency inversion principle. We are finishing up our section on the solid principles, going to be talking about the dependency inversion principle, my favorite principle of all 5 principles, mainly because I really do use it almost daily, and I find that it to be one of the most helpful. I didn't fully understand why. But the more and more I've practiced the solid principles, the dependency inversion principle has been a crucial one for me to maintain my code and make sure that it's clean and does what it needs to do. So what is the idea? You're going to see if you go and you do a Google search on the dependency inversion principle, you're going to see something like this. High-level objects should not depend on low-level implementations, or high-level modules should not depend on low-level modules. Something very similar to that. And you might say, okay, so what does that mean? Well, three main things, and kind of duplicated this, but duplicated the first and second one. We want to depend on abstractions. That's supposed to be on. And abstractions should not depend on low-level details. And we just want to generally support abstracting our code. Now, the dependency inversion principle is quite unique in the fact that there are several great ways that you can use this. And we've talked, and remember, it relates to object-oriented programming, the solid principles. And in our code, I'm going to give you an example how I use it almost every day by creating mocks for testing and making sure that it is the test mocks match our actual implementation that matches our actual abstraction class so that everything is synced up and working well together. So let's go ahead and dive into it. So let's take a little bit of some Angular code. This is going to be a mixture of TypeScript and Angular, and what we're looking at is a service here. So this service is going to go and do some API call. Our service is called Hacker News Service, and we're saying, it's pretty normal. It's nothing out of the ordinary, but it's not utilizing the dependency inversion principle, which would have us abstract an interface to allow us to not only extend this, but make it so that other dependencies that are dependent upon this class are. And so let's say we wanted to mock this file out for testing purposes because we already have our test, make sure Hacker News Service is doing what it needs to do, but we don't necessarily want to actually use the actual implementation and make those API calls, obviously. So we're going to have a mock class, but there's nothing tying these two together. At the very least, we can tie them together and make sure that we don't have an issue with our mock not matching what it's supposed to be. So how might we solve that? Well, if you had a interface, in this case we're using an abstract class, but it's the same idea. But if we had a interface to invert the dependencies so that we don't really care about the low-level dependencies, and the low-level in this aspect is the actual implementation of the mock, the implementation of the actual service, and instead we're just going to define the actual class itself, like so. What we're going to do is we're going to take this and we're going to extend the iHacker News Service, which is fine. What is the issue here? Oh, this is just some TypeScript stuff. Actually, we're going to use implement, so I don't have to. It's same thing, more or less. And so now we're saying, okay, cool. We actually understand that it has everything it needs for iHacker News Service, and we might find out that our mock is doing it wrong. It might be that there's an issue there. So let's go ahead and implement iHacker News Service. And in this case, it's still the future decorator, but I thought this was going to blow up, but didn't. But now, both of these are extending the correct dependency. It is extending the abstract class or the interface. Now, in TypeScript, we have a way of injecting the interface, and that would be how we would actually consume this, is we would inject the interface into the class, and then depending upon our dependency injection method, in Angular, you have modules that handle that. It would inject your actual service itself, while providing the interface. Let's go ahead and let me show you some code of where you might do something like that. So here we're looking at the module, which is how Angular handles its dependency injection, or handles its managing of dependencies, might be a better way of saying that. And you'll see that we are providing the abstract class that doesn't do anything, but it is there to say this is what is expected of our service. This is what our service should be doing. We don't really care how it does it, just as long as you meet the requirements. And then when we actually go and want to have the actual instantiation of that Xstrep class, which is the actual surface itself, use this class, use that class. And then if we had like a component, if we were to do a component, we'll just comp.component.ts, and we want to now it's getting a little angular free, but if we had a component like so, that's supposed to be component, and we want to export whatever, export class, something. In the constructor, the dependency we inject is the actual interface. And then it's just going to go and pull that class because we've inverted our dependencies. So we made sure our dependency injection done that. That's just a little more of how you might actually use it. But you get the general idea is that if you're going to have something mocking a service, or you're going to, which you will, and you want to have a high level object maintain what everything does, if you want to think of it that way, and then extend that out or implement it out. And that's a very realistic item that I use quite often for the dependency inversion principle. But anyhow, guys, I hope you found that helpful. As always, don't forget to comment, like, subscribe, share, all that good stuff. If you're interested in any of my courses, I highly recommend the 100 Algorithm Challenge to help you ace your next technical interview. There's a link in the description below. Get it just for $10. I'll see you guys next time. Bye.